coconut harvesting robot, printing a keyboard, battery-free Game Boy, and Nintendo's new Game & Watch. Stick around to find out more in this episode of News Bytes. Hello and welcome to Advanced Ingenuity Labs, your insight into technology. I'm your host, Aisha Sharif, and this is News Bytes, where we cover innovative developments in the latest technologies. As India's working population progressively moves towards more technical careers and away from riskier labor jobs like coconut harvesting, a shortage of coconut harvesters has become an issue. Coconuts have to be harvested every 45 days, and farmers are finding it increasingly difficult to find professional pickers. As an innovative solution, engineers have built a tree-climbing coconut harvesting robot that may be just what the coconut farmers are needing. Engineers at Amrita Vishwa Vidyapitham University have designed and built a prototype robot to harvest coconuts. This tree-climbing coconut harvesting robot may soon be mass-produced. The prototype robot, called Amaran, has been in development for 3 years and is currently on its 6th version. It takes about 15 minutes for Amaran to be manually assembled around the base of a coconut tree. The robot is composed of a ring-shaped body which can be adjusted to fit around the base of different-sized coconut trees. It has 8 inward-facing omnidirectional rubber wheels which move the robot to the top of the tree, also known as the coconut zone. Amaran is wirelessly controlled from the ground via a handheld controller or through a smartphone app, which allow the operators to move the robot up and down and around the tree. Once the robot reaches the coconuts, it extends its arm and gets into the correct position. Then using its circular saw, it cuts down the ripe coconuts. After landing on the ground, the coconuts can then be easily harvested. In field tests conducted at a coconut farm, the robot successfully climbed trees up to 15.2 meters in height with trunk inclinations of up to 30 degrees. Compared to Amaran, human coconut harvesters are faster at completing the task. However, the fact that the robot can go for much longer periods of time before needing a break could possibly make up for the time difference. Amaran may end up in the field collecting the coconuts we all love within the next few years. This is yet another example of real-world issues being solved through innovation and technology. A team of engineers at Purdue University have developed a new technology that is able to turn sheets of paper and cardboard into a human-machine interface. They hope this new technology can help transform sheets of paper from a standard notebook into a music player interface or to make food packaging interactive. Purdue engineers developed a simple printing process which can render any paper or cardboard packaging into a keyboard, keypad, or other easy-to-use human-machine interface. Ramses Martinez, an assistant professor in Purdue's School of Industrial Engineering and in the Weldon School of Biomedical Engineering in Purdue's College of Engineering, states, "This is the first time a self-powered paper-based electronic device is demonstrated. We developed a method to render paper repellent to water, oil, and dust by coating it with highly fluorinated molecules. This omniphobic coating allows us to print multiple layers of circuits onto paper without getting the ink to smear from one layer to the next one." Martinez further explains that this innovation facilitates the fabrication of vertical pressure sensors, which do not require an external battery since they harvest energy from contact with the user. This may easily be implemented converting basic cardboard boxes into interactive devices that may be used for many different purposes, such as package authentication, using patterns, signatures, codes, etc. According to the research team, standard sheets of paper can also be used as a music player interface, allowing users to choose songs, play them, and change the volume levels during playback. This technology is compatible with conventional large-scale printing processes and can easily be implemented to rapidly convert conventional cardboard packaging or sheets of paper into smart packaging or a smart human-machine interface, respectively. Unfortunately, there isn't any indication as to when this new technology will be available for the consumer market. However, some of the technologies developed have already been patented, and the university is searching for companies to which it may license this technology. If you enjoy this video and find value in our content, you can help us by sharing it with others. Also, leave a comment as we want to hear from you, and consider liking the video and subscribing to our channel. You may also click the notification bell if you don't want to miss our upcoming videos. To stay informed about our upcoming training courses and camps here at Advanced Ingenuity Labs, visit our website at advancedingenuitylabs.com and sign up for our email notifications. As we discussed in one of our previous episodes of News Bytes, batteries are intertwined with the fabric of our lives. However, battery-free computing is being developed to alleviate the inconveniences of conventional batteries. The goal of battery-free computing is to reduce our reliance on batteries, which are costly, environmentally hazardous, and ultimately end up in landfills. A team of computer scientists from Northwestern University and TU Delft in the Netherlands set out to explore the limits of battery-free computing and have developed the first ever battery-free, energy-harvesting, interactive gaming device called Engage. They'll demonstrate the Engage on September 12th during the 2020 virtual UbiComp conference. The team has built a fully operational Game Boy, which can play any of the console's titles, from Tetris to Super Mario Land. It harvests energy from 5 small rows of solar panels on its face and from button presses made by the user. In its present state, it can power the Engage for about 10 seconds, depending on the game, before losing power. A few quick button presses restores the gameplay in less than a second. Unfortunately, energy harvesting techniques aren't yet efficient enough to prevent intermittent failures, presenting a huge problem for gaming systems. For many of the original games, every time the console would switch off, your progress would be lost. To prevent the loss of game progress, the team engineered a new layer of software for saving games, allowing all data to be saved and restored within milliseconds. Josiah Hester, co-lead researcher, summarizes by saying, "We're basically saving really quickly and restoring from our saved game really fast without anyone seeing." The Engage is not a one-to-one recreation of the Game Boy. Rather, it's a redesign built from the ground up with modern computing techniques, driven by a Game Boy emulator. Also, the Engage isn't a device that's for sale. Instead, it's a research and development tool which serves as proof that battery-free devices can be interactive and encourage user interaction. The Engage serves as a starting point to help the industry and consumers consider the impacts of battery use. The design, hardware, and firmware are all open source and will be available on GitHub for anyone to use after their September 12th demonstration. A short technical write-up will also be available at freethegameboy.info. I'll leave a link for it in the description. Przemysław Pauzak, who co-led the research, says, "We're really making a huge leap towards useful and usable systems that are built upon this foundation of intermittent computing. Sustainable gaming will become a reality, and we made a major step in that direction by getting rid of the battery completely. With our platform, we want to make a statement that it is possible to make a sustainable gaming system that brings fun and joy to the user." I look forward to seeing how the obstacles the researchers overcame and the breakthroughs they've achieved advance the development of battery-free technology. Now that we all have feelings of nostalgia for the original Game Boy, I'll end this episode with some exciting news from Nintendo. For the 35th anniversary of Super Mario Bros., Nintendo is releasing a new Game & Watch. The Super Mario Bros. Game & Watch is an homage to the original, which was produced by Nintendo from 1980 through 1991, and was a predecessor to the Game Boy that was released in 1989. This new handheld will come with Super Mario Bros. 1, The Lost Levels, originally released in Japan as Super Mario 2, and a new version of Game & Watch Ball, where you'll be able to play as Mario instead of Mr. Game & Watch. Aside from these games, you'll be able to use the Game & Watch as a portable clock, though ironically, not as a watch. It'll be a must-have for collectors and Nintendo fans. The Game & Watch Super Mario Bros. Will be released on November 13th in limited production for $49.99. Pre-order information is not yet available. However, I'll include a link to Nintendo's Game & Watch website in the description. I can't wait to get my hands on the new Game & Watch. Are you going to jump in line to get this collectible handheld? Let me know in the comments. That's it for this episode of News Bytes. As always, if you enjoyed this video and want more, leave me a comment and consider liking and subscribing. See you next time.